All right, we're going to look at some problems from section 4.3, or sorry, 9.3. Again, we're still in our trigonometry unit. And so here, in these first four problems, they're asking us to find the measure of each angle. And you can use your calculators. I'll have mine here. Nothing wrong in that. So notice here, okay, we are going counterclockwise, so we know that's going to be a positive angle measurement. As I follow along, I've gone around one time. Well, that's 360 degrees. And then as I keep going, I am 35 degrees short of 180. Okay, so if I do 180 minus 35, that tells me that this portion is 145. The whole thing to here was 360. So when I add 360 to that, we get 505 degrees. Okay, here we're going clockwise, so we know we have a negative angle measurement. This is negative 90 degrees here, plus another 25, and that's negative 115 degrees. Okay, our next two are in radians. So again, we're going in a counterclockwise direction. So we know that that's a positive angle measurement. One complete rotation is 2 pi radians. We're going to add pi over 6 to that. So we want a common denominator. So that's 12 pi over 6. Plus the 1 pi over 6, we get 13 pi over 6 radians. And then our last one here in this section, we're going back to clockwise. So we know that we're going to be a negative angle measurement. So here's our one rotation. So that's negative 2 pi. There's half of a rotation. So that's adding to that or subtracting another 1 pi. And then we have another pi over 4. So combine those, 2 and 3 pi, that's negative 12 pi over 4 minus a 1 pi over 4. And that gives us negative 3 pi over 4 radians. Okay, moving on to a couple of other types of problems. It says draw the angle and now find the reference angle. Remember, the reference angle is the angle formed between the terminal side of an angle and the positive, or no, sorry, just the x-axis. So I'm just going to sketch a set of axes. So negative 470 degrees. So we know that we're going clockwise. So again, all the way around is 360. Right, so if I do 470 minus 360, that tells me I need to go another 110. Well, that's another 190, or I'm sorry, another 90. So then I got to go another 20. So there's our angle. And that's a 20-degree angle. So here is our reference angle between the terminal side and the x-axis. And so that reference angle is 70 degrees. Okay. Here we have 340 is positive. So we know that we're going counterclockwise. And 360 degrees is a complete rotation. And so notice we are 20 degrees short of that. And so this reference angle between our terminal side and our x-axis is 20 degrees. Okay, so now we're back into radian mode. And so negative, so we know we're going clockwise. And so I would break this up into negative 9 pi over 9, and then we're left with the negative 2 pi over 9. And I do that because this is 1 pi or negative 1 pi, which is half a rotation. So there's your negative pi. Now we just need to go another 2 pi. And so that leaves that reference angle. Maybe a little neater there. Is 2 pi over 9. Okay, here 17 pi over 6. So again, I'm going to break this up into 12 pi over 6 plus a 3 pi over 6 plus a 2 pi over 6. And I'll look at it a little bit of a different way as well. That is 2 pi, and again, we're going counterclockwise, so there's 1 rotation. I did the 3 pi over 6 because that's also pi over 2, which is a quarter rotation. And now I need to go another 2 pi over 6. And then that leaves me with 1 pi over 6 is our reference angle. Another way you can look at that is 17 pi over 6 is just pi over 6 short of 18 pi over 6. Now 18 over 6 is 3. So 3 pi would be 1 complete rotation and a half of a rotation. And so then there's our pi over 6 short of that 1.5 rotation. So 2 different ways to look at finding that reference angle. Okay, now we're going to get into evaluating some trig functions, and they want us to find the exact value here. So notice we're negative 1035. And I can see if I trace this, there's once, twice around, and then not quite a third time. So I say, all right, I've got 1035, subtract out 1 rotation, subtract out a second rotation, and I'm left with 315 degrees. Well, so that means that in our third rotation, we've gone around 315 degrees, which means I am 45 degrees short of a full rotation, which makes that reference angle 45 degrees. So now the tangent of this angle is the same as the tangent of 45 degrees. Now remember, we do have to take into account the signs, positive or negative. And because we're in the first quadrant, we know that all of their trig functions are positive, so I don't have to worry about that. So I could draw my 45, 45, 90 right triangle. And there are our side lengths. And so the tangent would be 1, opposite over adjacent. Okay, so here now we're finding the cosine of negative 135. We're in the third quadrant. Here's our reference angle. So I'm going to do 180 minus 135. So again, I have another 45 degree angle there as our reference angle. So I can use this triangle. So the cosine of negative 135. Now, because I'm in the third quadrant rather, right? The cosine is negative because remember cosine being x over r, the adjacent side over the hypotenuse. And in our second and third quadrant, the x coordinates are negative, so my cosine is negative. So it's the same as negative cosine 45. So here's 45. Cosine would be 1 over root 2, or root 2 over 2. And that would be negative. Okay, down here, again, we're going negative 120. So I know that is a 60 degree angle. So there is my reference angle. So if I were to draw a triangle over here, 60, 30, so that's 2, that's 1, that's root 3, right? That's one of those things that we really need to somewhat memorize, or you can draw the equilateral triangle and cut it in half. So sine in the third quadrant, because our y is negative, remember sine theta is y over r. And the y values are negative, so this is going to be negative. So the sine of negative 120 degrees is the same as negative sine 60 degrees. So here's 60, sine is opposite over adjacent, or over hypotenuse rather, and because we're going to be negative, we get negative root 3 over 2. Okay. Last one on this page, we're looking at our cosecant. So again, we've gone around once and then a little bit more. So actually twice rather. So if I take 870 minus 360 minus another 360. So in our third time, we're only going around 150. Since that's all 180, that's 30 degrees. So there's our reference angle. Now remember, Cosecant is 1 over sine, so it's the reciprocal of sine. Sine in our second quadrant is positive because the y value is positive. So if I find the sine of 30, so here's 30, opposite over hypotenuse, 1 over 2. So that's 1 over 2, the reciprocal, and that would be 2, and it would be positive. Okay, just a couple more. Now what we're doing is we're given a terminal side. So we're going to have to draw the right triangle. This is not going to be one of our special right triangles. So here, that means, and I'll draw a bigger triangle here. The x-coordinate would be this side. There's the y-coordinate. That's our 3, 4, 5. So secant, remember, of an angle is 1 over the cosine. And we are in the first quadrant, so that we know that cosine and everything is positive in there. Okay, so we have 1 over 3/5, which is 5/3. Okay, so again, here we are in the second quadrant. And I'm going to draw here's our triangle. There's our reference angle. So the adjacent side here, -7. That side is 15. Using our Pythagorean theorem, this side would be 8, not 64, the square root of that. So the cosine of that angle using our reference angle, it's going to be negative because we're in the second quadrant, would be -7, the adjacent side, over the hypotenuse, 8. Okay, we've got 2 more here. Tangent, here we are in the third quadrant. Here's our reference angle. So drawing our triangle. The adjacent side here is -5. That's -√11. And so that's going to be 7. Nope, sorry, 6. We use our Pythagorean theorem. Tangent of that, opposite over adjacent. Tangent is positive in the third quadrant, and notice we have a negative divided by a negative, so that would be √11 over 5. And then one more. Here we are in the fourth quadrant, sine. Again, this is our reference angle. So there, the x-coordinate, the y-coordinate, there's our hypotenuse. So the sine of that is opposite over hypotenuse. Because we're in the fourth quadrant, sine is negative, so we have -√5 over 3. Hope that helps, and we'll see you soon.